Two-step algebraic equations. I can solve multi-step algebraic equations.
Nice job. Like terms. Ben, what are like terms?
Terms that have the exact same variable.
Very, very important to remember or to know what a like term is. So if I am dealing with the variable a and I'm dealing with another variable a, regardless of what's in front of it, are they like terms?
Yes.
If I'm dealing with the variable a squared and the variable a squared, regardless of what's in front of it, are they like terms?
Yes.
If I'm dealing with the variable x and the variable x squared, are all the variable parts the same?
No.
Therefore, those are not like terms, right? Right?
Yes.
Right.
What is the name of the number that's in front of a variable? Everybody.
Coefficient.
Coefficient is the name of the number in front of a variable. Quick question, we didn't talk about this. If you have the variable x, and I asked you for the coefficient, what would you tell me? Yes, you would. How many x's do I have up there? X is the same as 1x. Just like if you had 2x, what's the coefficient in front of the x?
2.
How many x's am I talking about?
2.
So anytime you're dealing with a variable and there's nothing in front of it, you can assume the coefficient is going to be what? Please keep that in mind. Part 2, we combine like terms. Remember our coding system? Remember our coding system? Okay, 3 and 4, pretty simple. We have x and x, so we have the exact same variable parts, therefore, we can combine. Number 4, we have x squared and x. We do not have the same variable parts, so we cannot combine. And then when we got into 5, 6, and 7, because we had so many different things going on, we decided to box and circle and triangle and color code our variables. So in number 5, x and y would be the variable part, and x and y here would be the variable part. So we boxed the 7xy and the 2xy because we know those two are going to be combined. 12 is just a basic number. Our negative 12 was a basic number. Is there any other basic numbers in number 5? No. And then x squared y, are there any other variable parts that are x squared y? No. Therefore, those are just separate and on their own. Okay, number 6 is very similar, a little bit longer. I'll let you look at that one on your own. When you distribute, you do what, everybody? Read the definition on the count of 3. 1, 2, 3.
To spread out evenly.
And distributing is only involves what operation?
Multiplication.
Multiplication. And a really good hint that you should distribute would be that you're going to see what? Parentheses. And outside of the parentheses is going to be the number you're going to distribute. And as it said, you multiply or spread out that number in front of the parentheses evenly to distribute through. You with me? Okay, and then number 4, our last idea, solving multi-step equations. On a question or on a problem like number 10, Annika, we have 2x minus 4 equals 12. Why, Annika, did we add 4 to both sides first? We want to get the variable alone now, but Annika, we know that to undo 2 times x, we can divide by 2, right? Why didn't we divide by 2? Why did we decide to add 4 instead of divide both sides by 2? Can somebody tell me why did we do that, Alexis? It's the easier step, right? So when you look at this problem, what do you feel is easier? Dividing both sides by 2 so that you get x minus 4 halves is equal to 12 halves, or simply add 4 to both sides? What's easier? Add 4. Anytime you're dealing with multiplication and division or addition and subtraction, most people are going to say, I'd rather add and subtract. Seems easier. In school, what's the first thing you learn? Adding and subtracting or multiplying and dividing? So, if anything, think of it like that. Since I learned adding and subtracting first, I'm probably better at it. So do that first in your algebraic expressions or equations. Yes or no? Okay, what's it called? Okay, bear with me here. I added 4 to both sides. What's it called when I do this next step? So I had 2x minus 4 plus 4 and it ended up with 2x. What do I call that? Clean it up, right? So if I have 12 plus 4 and I clean it up, what do I end up with? 16. And then I divide both sides by 2. When I clean it up, what do I got left here? What do I got? X equals 8. Okay, so when I'm talking about the cleanup stage, that's what I'm talking about. We're going to skip over number 11. You can use that for your own reference. We're going to skip over number 12, which I think some of you did in class, and it looks beautiful. Number 13, really important on 13. What did we do before we started solving? We had 3x, we had 7, and we had 12x. We combined like terms first, right?
Yeah. Yes.
Wonderful. And I'm going to skip down to number 14. What did we do on this problem? We had 2/3 x plus 1/2 is equal to 3/4. We love working with fractions, right?
Yes.
Yes or no?
No.
Not so much, right? Do we want to work with fractions or would we rather work with non-fractions?
Non-fractions.
So remember, we took the numbers 3, we took the number 2, we took the number 4, all the denominators, and we found the L.
CM.
And the LCM of 3, 2, and 4 is what?
12.
And 12 is the same as 12 over?
1.
Wonderful. And when you distributed 12 through on both sides of the equation, it became 8x plus 6 equals 9 instead of 2/3 x plus 1/2 equals 3/4. Which one would you rather deal with? 8x plus 6 equals 9 or 2/3 x plus 1/2 equals 3/4?
8x plus 6 equals 9.
Last thing, I know this video is getting kind of long, but lots of good stuff in here. Number 15, what's the first thing we did before we started solving?
Distribute.
You distributed. Okay, distribute first, then we got rid of our fractions, then we solved for the variable, which my friend who? My friend who?
Tiffany.
Told me to do.